For years, astronomers have dreamed of seeing another world the way we see our own. Clearly, directly, and undeniably real. Not a blurred signal, not a distant shadow, not a simulation stitched together from data, but an actual image of a planet orbiting another star, a world with its own sky, its own atmosphere, and its own story. And now, for the first time in human history, the James Webb Space Telescope has done exactly that. It has captured the first real image of another world, a world that shouldn't exist where it is, a world stranger than anything we imagined, and a world that is already rewriting the rules of planetary science. But this image was only the beginning, because as the James Webb Space Telescope continued observing, it uncovered something even more shocking. Other planets with impossible chemistry, mysterious atmospheres, broken rules of formation, and one that may even hold the strongest hints of alien life we've ever detected. Tonight, we're going to step into that first image and follow the trail of discoveries it unleashed. K2-18b was never meant to be the center of global scientific debate. At first, it was just another distant super-Earth, too large, too far, and too difficult to study with the instruments we had at the time. But when Webb pointed toward it, the telescope didn't just collect data. It peeled back the atmosphere itself, layer by layer, molecule by molecule. The James Webb Space Telescope revealed a world wrapped in a dense envelope of hydrogen, beneath which may lie something extraordinary, a global ocean deep enough to swallow mountains whole. Water vapor appeared immediately, strong and unmistakable. But what came next pushed this planet into scientific history. Webb detected methane, carbon dioxide, and then the molecule that sent shock waves through every observatory, dimethyl sulfide, a chemical that on Earth originates almost exclusively from life in our oceans. This wasn't noise. It wasn't distortion. It repeated across multiple observations. Suddenly, the idea of a dark, endless alien ocean didn't seem fictional. It seemed probable. A world where sunlight filters weakly through a thick atmosphere, warming the boundary between day and night into a stable, habitable twilight. A world where life, if it exists, could rise slowly and silently, forming ecosystems unlike anything on Earth, yet governed by the same universal chemistry. Scientists didn't want to say it, but they had to admit it. If any planet we've ever studied can host life, K2-18b may be the first real contender. When Webb captured the first real image of HIP 65426b, astronomers expected a typical gas giant, massive, distant, and predictable. But the image revealed something far stranger. HIP 65426b is a colossal planet nearly 7 times the mass of Jupiter, orbiting so far from its star that it shouldn't exist at all. According to every planetary formation model we have, giants this large must grow inside the swirling disk of dust and gas that surrounds a young star. But this world sits far beyond that region, alone in the darkness, as if it formed in a completely different place and arrived later. The mystery deepened when the James Webb Space Telescope analyzed its light. Instead of the smooth atmospheric profile expected from a gas giant, HIP 65426b displayed unexpected chemical layers, strange variations in temperature, and cloud structures that defied stability. The atmosphere didn't behave like a planet peacefully evolving in a star's orbit. It behaved like something unsettled, something that had experienced violent changes or had traveled across different environments before reaching its current position. This led scientists to propose theories that once seemed unthinkable. Perhaps the planet was ejected from another star system during a chaotic collision and later captured by its current host. Or maybe it formed alone in the cold darkness of interstellar space, a rogue planet wandering for millions of years until gravity finally claimed it. But the most intriguing possibility is the one astronomers whisper more than they admit, that HIP 65426b isn't just an anomaly. It's a clue, a sign that solar systems may form in ways we've never imagined, that planets can migrate enormous distances, and that the universe is capable of assembling worlds through mechanisms we haven't even begun to understand. Webb's first real exoplanet portrait wasn't simply proof that other worlds exist. It was a message. These worlds are stranger than anything we expected, and the next ones would push the mystery even further. Proxima b has been called the most tempting planet in the galaxy. At just over 4 light-years away, It sits in the habitable zone of Proxima Centauri, the closest star to our Sun. From the moment it was discovered, astronomers imagined oceans, atmospheres, and maybe even the faint silhouettes of continents beneath alien clouds. It was everything we hoped to find in an exoplanet, close, rocky, and sitting in the perfect temperature range for liquid water. But when the James Webb Space Telescope turned its gaze toward this nearby world, the excitement quickly became frustration. Proxima b orbits too close to its star, so close that the planet disappears into the glare, making its atmosphere impossible to observe directly. The James Webb Space Telescope cannot separate the light reflected by the planet from the violent radiation of its parent star, leaving us with a world we can detect, but not truly see. And then a deeper problem emerged. Proxima Centauri is not a calm star. It's a red dwarf prone to massive solar flares, bursts of radiation, so intense they could strip a planet's atmosphere in a geological heartbeat. If Proxima b once had oceans or a breathable sky, they may have been blasted away long ago. Or worse, the planet could be locked in a permanent twilight, one side scorched and the other frozen, clinging to habitability only in a thin band between day and night. This paradox is what makes Proxima b one of the most haunting discoveries Webb has revisited. It is the world closest to us, the one we dream of visiting, the first destination in any future interstellar mission. Yet it may be forever beyond our reach and understanding. We can detect its presence, measure its gravity, sense its temperature, but its mysteries remain concealed behind the blinding fury of its star. Proxima b reminds us of something humbling.